Okay, hi class. So, I'm sorry I'm not there today. I am sitting in lovely jury duty today, so I will hopefully have many stories to share. Alright, so today we're doing 3.3, solving inequalities using multiplication and division. So we did addition and subtraction on Friday. Now we're moving into multiplication and division. So, make sure your name is on your paper. There you go. Smarty Pants, that's your name, right? Okay, so warm up recap from yesterday. Not really yesterday, but we're solving. So either by adding or subtracting. So we've got x plus 3. We want to get rid of that plus 3. So we are going to need to subtract 3 from both sides. Now if you want, you can draw that dividing line down to show the separation. Okay, so plus 3 and minus 3, we get 0. We're just left with x now. Carry the sign down. 10 minus 3 is 7. Now we have something that we can graph. So put your 7 on the number line. Decide, open or closed circle. I feel like Dora right now. That's right, closed circle. All right. From here, we need to decide which way to fill in. X is less than or equal to 7. Less than, so think the numbers need to be smaller than 7. So we're going to fill in to the left. Like Beyonce said, to the left, to the left. All right, next one. We've got x minus 7. So to get rid of that minus 7, we need to add 7 to both sides. Draw that dividing line to show you. Alright, there's a lovely straight line. Okay, we now have x is less than or equal to negative 2 plus 7. We need to be at positive 5. So, third positive 5 on the number line. Decide, open or close circle. Close circle because we have that or equal to. We want to include that 5. That's why we fill in our circle. Now decide, do we need to fill in left or to the right? X is less than or equal to 5. So less than, we're going to get smaller. Go to the negative side, the dark side. Okay. All right, moving on. So we are solving one-step inequalities by multiplication and division. All right, so before we look at how to solve these inequalities using multiplication and division, let's get rid of those variables, okay? So, first thing, follow along. We've got 3 is less than 8. That is a true statement, yes. Now, first thing I need you to do, it says add 11. We're going to add 11 to both sides. So 3 plus 11, we end up at 14, is less than 8 plus 11, 19. Is this still true? Yes, it is. Okay, next one. It says minus 7 on both sides. 14 minus 7 is 7. Keep the sign. 19 minus 7 is 12. Is 7 less than 12? Is this still true? Yes, it is. Okay. Next line. We're going to multiply by 2 on both sides. So 7 times 2 is 14. 12 times 2 is 24. Is this still true? Is 14 less than 24? Yes, sir. All right. Last thing we're going to do. We're going to multiply by a negative 3. Let's see what happens. So 14 times a negative 3, negative 42. Keep the sign. Negative 3 times a 24, negative 72. Is negative 42 less than negative 72? No way, Jose. So, let's think about this. How could we make it true? What's the relationship between negative 42 and negative 72? Negative 72 is less than negative 42. So to make this statement true, we need to flip that sign. So right here, we had a less than sign. We flipped it to be a greater than sign. So we flip the sign. Now, the only time when we ran into a problem was when we multiplied by a negative 3. Okay? Alright, let's move over, try a different one. Got 10 is greater than 2. Is this true? Yep. So, let's try it. Add 20 to both sides. So we should get 30 is greater than 22. Is this still true? Yes, sir, Bob. Alright, next. Subtract 2 from both sides. We get 28 greater than 20. Is this still true? Yes, ma'am. Okay, next one. Divide by 2 on both sides, it says. We get 14 is greater than 10. Is this true? Yes, it is. 14 is bigger than 10. Alright, last one. Dividing by a negative 3. Alright, we're going to get into some fractions here. So we've got negative 4.6 if I round. Keep our sign. 10 divided by negative 3, we get negative 3.3. Wait a minute. Negative 4.6 is greater than negative 3.3. Is this true? No way. Alright. Pesky negative. How could we make this statement true? What's the relationship between negative 4.6 and negative 3.3? Flip your sign. We've got greater, then we put in a less than. Okay, so again, flip sign. Okay? So, from those examples, what was the issue? Multiplying by a negative and dividing by a negative. Those are the issues. So, fill in your blanks here. When we multiply or when we divide by a what type of number? Negative. We need to flip our sign. Okay? Flip it. Make it go the other way. Okay? Alright. So, this does not say anything about adding and subtracting negative numbers. It is only multiplying and dividing negative numbers. That's when you flip. Okay, so let's try it out. So we want to solve. We've got 2 times x. I want to get rid of the 2 times x. So I get x by itself. I need to do the opposite operation. The opposite of multiplication is division. So we divide by 2 on both sides. Alright, I divided by a positive 2. Is that part of my rule? Nope. Not a negative. It doesn't matter. So I get to keep my sign. We have 14 divided by 2 is 7. This is something I can graph. Throw 7 on there. Open or close circle. Open. Good, class. Okay. X is greater than 7. X needs to be bigger than 7. So which way am I going to go? To the right. Fill in that arrow to show that it goes on forever to infinity. Okay? Alright, next example. X divided by 3. Draw in that dotted line if you want to show the separation. X is being divided by 3. We need to do that opposite operation. So opposite of division, multiplication. Get the 3 out of the denominator, so we multiply by 3. They cross out. We're just left with x is greater than 5 times 3 is 15. Okay. This is something I can graph. I did not flip my sign because I was multiplying by a positive. So, throw 15 on here. Open or close circle. Open. Now, x is greater than 15. X needs to be bigger than 15. So go this way. All right. Take a minute, look it over, and in a minute we will flip to the next side.